All right, our next method of factoring is difference of two perfect squares. All right, and difference of two perfect squares requires certain aspects in order to do this. You're still always looking to factor out a GCF first. That's always kind of your first step. However, after you do that, difference of perfect squares can occur when there's only two terms. That's why it's called 2. Both terms are perfect squares. And the terms are being subtracted. Remember, perfect squares are numbers that you can take the square root of and get a whole number out. Or they're numbers that you can take a number and square it or multiply by itself. That's the perfect square. So for example, 0 times 0 is 0, so 0 is a perfect square. 1 times 1 is 1, 1 is a perfect square. 2 times 2 is 4, 4 is a perfect square. I'll label these. These are perfect squares. 3 times 3 is 9. 9 is a perfect square. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. Now, those keep going forever. Other perfect squares, though, is x squared, because x times x is x squared. Or y times y is y squared. Or x to the fourth, because that's x squared times x squared. Okay, so keep those in mind, that you're going to have variables that are really any even exponent would be a perfect square. So you have a formula for difference of squares. And the formula looks like this: a squared minus b squared. Okay, so this is what you have. It's a perfect square because it's some number squared minus some other thing squared. Okay, so there was two terms. They're both perfect squares. Could put the squared on it, and they're being subtracted. And this right side is going to be your factored form. So you have two sets of parentheses. So this is like the reverse of FOIL now. And you take whatever happens here, you take the square root of the first term here, which is square root of a squared is a. So I have that first term square rooted, goes in the front of each set of parentheses. I take the square root of the second term, so square root of b squared is b. And that goes as the second term in both set of parentheses, and you always have opposite signs. So this is the factored form. So you take the square root of a squared, which is a, the square root of b squared, which is b. Okay, so that's how I got the a and the b. Took the square root of those terms. All right, if I look at my example, 25x squared minus 9, I still look for a GCF first. However, there's no variable that goes into both, and there's no common factor. The factors of 25 are 1 and 25, 5 and 5, and the only factors of 9 are 1 and 9, and 3 and 3. So there's no common factor. So if I notice, there's two terms that are being subtracted, and 25 is a perfect square, so is x squared, and so is 9. They're all on my list here. So therefore, what I'm going to do is, first off, and you don't have to necessarily do it like this, but the a squared in this particular problem will be the 25x squared, because that's the first term. The b squared would be the 9. And you don't write negative 9 because the formula has a negative in it. It's just 9. So that means to get a, I'd have to take the square root. So a would be the square root of 25x squared. So the square root of 25 is 5, and the square root of x squared is x. Because again, 5 times 5 is 25, x times x is x squared. And again, if I wanted to find out what b was, if b squared is 9, I have to take the square root of 9. What times itself is 9, which is 3. So if I'm looking at that formula, it's factored by saying the a plus the b times the a minus the b. So my a is 5x, so 5x plus 3 and 5x minus 3. So this is now factored. Again, notice there's multiplication between those parentheses. That's why it's factored, because it's separated by multiplication now. And if you don't believe yourself, you can double check your work here with FOIL. So again, this is just a check. You don't have to do this, but it's always a good idea to check. So 5x times 5x is 25x squared. 5x times negative 3 is negative 15x. 3 times 5x is positive 15x. And then positive 3 times negative 3 is negative 9. And what happens here is those middle terms, negative 15x plus 15x, add to 0. So I'm left with just the 25x squared minus the 9, which is what we started with. All right, if we look at number 1, I want you to try these. We have x squared minus 81. Always look for a GCF first. In this case, we don't have one. And I notice I have two terms. They are being subtracted. X squared is on my perfect square list, and so is 81. So what I'm going to do is write two sets of parentheses. I'm going to take the square root of x squared, which is x. That's going to go in the front of my parentheses. I'm taking the square root of 81, not negative 81, just 81. Square root of 81 is 9. And I have opposite signs. So I end up with x plus 9, x minus 9. And again, this is multiplication in there, so that means it's factored. Factors means separated by multiplication. For number 2, I have 4x squared minus 49. Again, I look for a GCF first. Well, the only thing that goes into 4 is 1 and 4, but 4 does not divide evenly into 49, or 2 and 2, and 2 does not go into 49, so there's no GCF. I notice I have two terms. They are being subtracted. 4 is a perfect square, x squared is a perfect square, so is 49. So again, I'm going to make two sets of parentheses. I'm taking the square root of 4x squared, which would be 2x. Square root of 49 is 7. And then you always have opposite signs. So 2x plus 7, 2x minus 7. And again, if you FOIL this out, you would get what you started with. If we look at number 3, 9x squared minus 16, look for a GCF. The only thing that goes into 9 is 1 and 9, which 9 does not divide into 16, or 3 and 3. And again, 3 does not go into 16 either. So there's no GCF. And then I notice there's two terms. They are being subtracted, and they are both perfect squares. So I'm going to take two sets of parentheses. Take the square root of 9x squared. Square root of 9 is 3. Square root of x squared is x. So 3x goes in the front of both sets of parentheses. I take the square root of 16, which is 4. That goes as the second term in each set of parentheses. And then you will always have opposite signs. So as you go and try the homework tonight, just be careful, because the homework tonight will have difference of squares. It will also have GCF, so the two types of factoring you have been working with so far. So please, please, please make sure you pay close attention. Always look for a GCF first, no matter what, and then from there you will look for perfect squares after that if needed.